Okay, so I asked you to kind of do this as a warm-up for a reason. I wanted to see if you remembered kind of the processes that we would use. So we don't try to tackle how many times 7 goes into this big, huge number, right? We really more focus on like how many times 7 goes into, we start with 43, right? So how many times does 7 go into 43? 6. So we put a 6 above here, right? And then what do we do with what we wrote on top? We multiply, right, and bring it down. So 6 times 7 is 42. So we multiply, then we subtract, and then we bring down the next digit, right? And then we kind of do the process all over again, right? We just kind of keep going until we have some sort of answer, right? So now we say, okay, how many times does 7 go into 11? And the answer is what, of course? 1. And then we multiply 1 times 7, which is 7. We get 4. So we bring down the next digit, which is 8. 7 goes into 48 6 times, right? 6 times 7 is 42. Subtract down the list, and we only have one more digit to bring down. So unfortunately, it doesn't go in evenly, right? Which means we're going to have a what? What's it called when you have a leftover? A remainder, okay? But 7 goes into 65 9 times, just not perfectly, right? 9 times 7 is 63. So we end up getting 2, and we call this the remainder. So actually, if I wanted the exact answer, the answer is actually 6,169 and 2/7. That's how you write the remainder. You write it as 2 over what you were dividing by. Okay. The point of this warm-up exercise was to get you to kind of get in that frame of thought. What operations were we kind of repeating all the time? We were multiplying, then subtracting, and then doing what? Bring down the next digit. And we kind of did that until we were out of terms, right? So then we repeated it over and over and over. So this process of multiply, subtract, bring down the next digit is going to be exactly the same process that we're going to use in a algebra method called long division, okay, where we actually divide things with x's in them, okay? But before you get freaked out by how that sounds, it's exactly the same method as this, which is why I had you think about that first. Okay, so kind of put that warm up off to the side. You can include it as part of your notes if you'd like to, but you certainly don't have to. So we're going to look at a process called long division. What we just looked at was called long division. And then we're going to look at a quicker process called synthetic division. But both of these are forms of division. Okay, and so let's talk about what we're doing here. So long division and synthetic division are used to divide polynomials by other polynomials. And sometimes we're going to get remainders, and then sometimes we're not. Okay? If a polynomial divides into another one evenly, we would not get a remainder. Okay, so let's just kind of go through the process, and then we're going to talk about kind of what we did. So let's say that I asked you to divide x squared plus 8x plus 5 divided by x plus 3. Okay, I promise if you could follow the warm-up, you can do the process we're about to do here. Okay, so the first thing we're going to do is set it up, just like we would if it was an old school number problem. And then one really good hint is try to just look at the first terms. So I'm going to underline those first terms. Okay, so if you look at the first terms, ask yourself a similar question to what we did before. How many times does x go into x squared? Or maybe said a different way, what would you get if you divided x squared by x? You would get x, right? So we're going to line that result above its like thing, right? We're lining it above the 8x since it's not 8x squared or anything like that, or x squared, I mean. So then we're going to start our process where we multiply, subtract, bring down. Okay, so if we multiplied this, just make sure we remember that we have to actually multiply it by both parts. So we're going to multiply down, and then we'll worry about what we do next. So what is x times x? X squared. What is x times 3? 3x. Okay, so far I've done the multiply step. Okay, what's supposed to come next in our process? Now we subtract. Okay, so when I subtract a polynomial something though, notice what's it going to do to my signs? It's going to change them. Okay, so notice x squared minus x squared is gone, right? And then what's 8x take away 3x? 8x minus 3x would be how many? 5x's. Okay, so what do you think the next third step is? Since we multiplied and subtracted, what's the third step going to be? Bring down. Okay, and then repeat if necessary. So we'll bring down the next term, right? And it'll be a what? Plus 15. And then we'll do the process all over again. Okay, remember we only look really at the first terms at first. So ask yourself, what would happen if I divided an x out of a 5x? What would I have left? Just a 5, right? So not a negative 5, but a positive. So I'm going to say plus 5. So then I still need to do my multiply, subtract, bring down thing, right? So I'm going to cover this up. I already took care of the x, so now what do I need to do with that 5 that I just wrote? Multiply, right? So 5 times x is 5x. 5 times 3 is 15. So I multiplied. Now I need to do what? Subtract. So that means change the what? The signs. So notice in this case, it ends up working out to be what in the end? Perfect. Okay, meaning that we have no what? No remainder. Okay, so what is my answer then for what the division process gives me? Yeah, my answer is what I had on top. Okay, my answer is x plus 5. Okay, so I'm going to kind of extend this out a little bit. Look at the first terms when deciding what goes on top of the divided by sign. Okay, by the way, because we got a remainder of 0, we can actually make a statement here. So because the remainder is 0, only because the remainder is 0, we can say that x plus 5, the answer we got, times what we were dividing by, must have been the same as what we started dividing into. Okay, but this again is only because the remainder was 0. We wouldn't be able to say that, in other words. In other words, said a simpler way, 20 divided by 5 is what? What's 20 divided by 5? 4, right? And then 4 times 5 gets you back to 20, right? So anytime you get no remainder, you can make that multiplication statement as well. Okay, so I know it's weirder, it's definitely stranger, right? But what 3 things did we kind of just keep doing just like we did with the old school division problem? Multiply, subtract, bring down, and then repeat if necessary, right? Okay, so let's try another one. 6x cubed plus 17x squared plus 27x plus 20 divided by 3x plus 4. So the first thing I want you to do is set it up like you would have an old school division problem. Notice that you're not going to get as much out of the lecture today if you just copy down what I write down. It's really more of a process that I want you to follow with me. Like, how did we decide what went where and all that good stuff. Okay, so what term did I tell you to kind of focus on at first? Only the first ones, right? So here are the first terms in both things. Okay, so y'all tell me, what would I get if I divided a 3x out of a 6x cubed? So 6 divided by 3 is what for sure? 2, right? What about x cubed divided by x? 2x squared, right? So notice that's where I'm lining it up. I'm lining it up above the other x squared thing, okay? And then I need to start my threefold process, right? What's the first step of my threefold process? Multiply first. Okay, so 2x squared times 3x is 6x cubed. 2x squared times 4 is plus 8x squared. So I multiplied, now I need to what? Subtract. Okay, by the way, every stage in the game, you should get this to happen or something's wrong. Okay, the first part of every step should go away. Okay, all right, so what's left? 17x squared minus 8x squared would be how many? 9x squared. Okay, so then what next? I multiplied, I subtracted, so now what comes after that? Bring down the next thing, which is plus 27x. And then I'll do the process again, right? Only looking at what terms every time? The first terms, right? So if I take 9x squared and I divide out a 3x, so let's do the numbers first. What's 9 divided by 3? 3, right? 12, yeah. You're thinking 12 divided by 3. And then what would happen if I divided an x out from an x squared? I'd just have an x, right? So notice it goes there, right? So now what? Now I multiply and then subtract, right? So it's helpful sometimes if you like cover that up, right? I already did that part, so now I'm just focused on the 3x. So what do I need to do with that 3x? Multiply times these two, right? So 3x times 3x is 9x squared. 3x times 4 is plus 12x. And then I multiplied, so now I what? Subtract. Okay. Notice what I said happens every time. What happens here? Cancels, right? And then I get 15x. And then bring down my last term, right? Plus 20. Okay, so this is going to be the last time because notice I don't have any more terms left, right? Okay, so if I divide a 3x out of a 15x, what would be remaining? 5, good. So now if I need to, I cover all that up, right? And what do I do with the 5 that I just wrote up there? Multiply, then subtract, and see if I have a remainder or not, right? So 5 times 3x is 15x. 5 times 4 is plus 20. So what do you notice? Are we going to have a remainder this time either? No remainder, right? This goes away, leaving 0. So what does that mean my answer is then? Yeah, the answer is what I got up top, right? So 2x squared, good, plus 3x, plus 5. Okay, and then again, we know now that 2x squared plus 3x plus 5 times the 3x plus 4 I was dividing by is definitely equal to what? 6x cubed plus 17x squared plus 27x plus 20, okay? But it's only because what? Yeah, it's because the remainder was 0. Okay, that would not be true if the remainder wasn't 0. So not only can we tell an answer, but we can actually make kind of a multiplication step about what we got to be our answer. So we're going to use this process of long division mostly to tell if something goes into something else evenly or not. Okay. But I do want to do a couple where we do end up maybe with some remainders so that you kind of know what that looks like. So let's do a couple more. So notice that I wrote this one a little differently, but what does a fraction bar still mean I'm supposed to be doing, like, operation-wise? Yeah, you're still supposed to be dividing. So we'll set it up just like we did before. And I know it's weird that what we're dividing by is longer than the others. But it really won't matter that much to us because we're only looking at which terms in general anyway. We're only looking at the first ones. So, I mean, it really doesn't change a whole lot for us, okay, other than the fact that we'll just have to multiply a little more carefully. Okay, so what's the question you ask yourself first? If I divide what? 3x squared out of 6x cubed. So let's do the numbers first. What's 6 divided by 3? 2. What's x cubed divided by x squared? X, right? So 2x, notice I'm placing it all the way over here, right? Because I have to place like things together. So then I have my threefold process, right? So I need to do kind of a three-part multiply step, right? Because there's 3 parts to what I'm dividing by. So I need to make sure 2x gets multiplied by all 3 of those. So 2x times 3x squared is what? 6x cubed. 2x times a minus x, careful of your signs, would be minus 2x squared. And then 2x times a negative 5 would be minus 10x. I always do it the same way every time. I write down what I get and then I change the signs. If you try to do them all at crazy times, you're going to forget what you did and what you haven't done yet. Because I do need to subtract, which means this is negative, but what happens to these guys? They become positive. Okay, notice, first term is gone, as usual. So what do I get here? It's actually 13x squared what? Plus 2x, so that would be how many? 15x squared. This is actually negative 11x plus 10x, so that would be plus x, right? Plus 1, or actually no, it'd be what? What's negative 11 plus 10? It's actually minus, right? Because it'd be like negative 1. And then what do I do after I subtract? I bring it down. So I'm almost done after this step because I don't have any more numbers to bring down or any more x value things to bring down. So now what? I asked myself, what would happen if I divided 15x squared by what now? 3x squared. And what's the answer? What is 15x squared divided by 3x squared? Just a regular old 5, right? Just the 5 goes there. Okay. So notice I'm going to cover this up because I already messed with it. So what do I need to do with that 5? Multiply down by 1, 2, 3 things, right? So 5 times 3x squared is 15x squared. 5 times a negative x is a minus 5x. Remember, just write down what you get and then change the signs after. 5 times negative 5 is negative 25. Why are we changing the signs again? Because we're subtracting, yes. Okay, so this becomes negative. This becomes positive. That becomes positive. So as usual, first term is gone. What about second terms when you combine them? What's negative x plus 5x? 4x. And then negative 15 plus 25 is plus 10. Okay. Notice that you couldn't keep going even if you wanted to, right? Because 3x squared cannot come out of 4x, right? It's too small, which means that this is all the what? This is the remainder. Okay, so I know we may not love the way this looks, but we're going to answer this just like we did the warm-up question. So the answer will be what we got up top. And then how do we write the remainder? We write remainder over what we were dividing by. So I know that might be kind of a weird and unsettling look to our answer, but that is our answer. Okay. Now, are we going to make a multiplication statement like we did before? Are we going to say like that times the thing we were dividing by equals the original? We're not going to say that because why? Because we don't have a remainder of 0 this time. Okay. So let's do one more like that, and then I'm going to just kind of fill you in on how my lab might want you to put in the answers. It's really not that big of a deal. But sometimes it wants the answers in just a bit different format. So 18x to the 4th divided by 3x squared. Something else that you can also notice is, notice I'm doing a 4th power divided by a squared power. So what kind of should the power be in my answer? If you divide a 4th by a 2nd, what would be left? 2, right? So we are going to get a squared answer of some sort, okay? So you can kind of make sure that the answer seems to make sense to you once we're done. So let's line it up. And on this one, place value is super, super important. So we need to remember that we're not allowed to add terms that are not alike to each other.
Both of those last exponent is 3?
No, 3 and a 2. 9x cubed and 3x squared. All right, so we only look at what to start off with? First term. Okay, so how many times does 3x squared go into 18x to the 4th, or said a different way, what's 18x to the 4th divided by 3x squared, and what is it? 6x squared. Notice I got to line that all the way up over there because that's where its like part is, right? And then what do I do with what I line up there? Multiply, and then I'll do what again? Subtract, bring down. Okay, so 6x squared times 3x squared is 18x to the 4th. So be careful about this. And then 6x squared times 1 is 6x squared, but where do I need to put that? I need to put it right here. In other words, you have to line things up with their like pieces. So when I go to change the signs, I just have to be kind of careful about like parts. Notice what still happens here as usual. That goes away, but notice this is not being added to anything, right? So what happens to it then? Yeah, it just comes down. It's just 9x cubed still. But these I can combine. What's 3x squared take away 6x squared? It'd be negative 3x squared, right? So now I have some more terms that I can kind of keep going with. Okay, so I only look at first terms again. Okay, but notice I'm going to need some more room here, right? So I'm just going to extend my division bar out a little bit, okay, and then we'll put some kind of placeholders there in a minute. So what would happen if I divided 3x squared from 9x cubed? 9 divided by 3 is what? 3. What's x cubed divided by x squared? 3x, right? So I'm going to line this right up here, and then if you like things to kind of be organized, I'm going to put a 0x there. Notice I'm not changing anything, I'm just putting it, having it a place to be, basically, a place to have its like part with. Okay, so we're done with this, so now let's take the 3x and do what? What two things do I need to do next? Multiply and subtract. So 3x times 3x squared is 9x cubed. 3x times 1 is 3x, so notice, I don't want to line that up here. Why not? It's not alike with that one, right? So that's why I kind of put that placeholder up top so that I'd have somewhere for those terms to go. Don't forget to change your sign because we're always subtracting. So that goes away. So what happens to the minus 3x squared? It comes down because we didn't do anything with it, right? It's still there. And then what's 0x take away 3x? It's still just minus 3x, right? So the question is, like, when do you know when to stop? And the answer is you stop when you can't do the division process anymore. But I say we still could do division here because I can divide a negative 3x squared by a 3x squared, okay? It might be the last thing that I can do, but I can still do it, right? So what is negative 3 divided by 3, first of all? Minus 1, right? And then x squared divided by itself would just go away, right? So I only get a plain old what? Just a minus 1 there, okay? So if I really like to have place values, I'm going to put a 0 there. Okay, notice putting 0 placeholders just put a spot for numbers to go. It doesn't really change the value at all. So then what do I do with that negative 1? Multiply it and then subtract it, right? So negative 1 times 3x squared is negative 3x squared. Negative 1 times 1 is minus 1, which can't go there. It has to go over here in its own little column. And then when I subtract, I change the what's again? Signs. So that's gone. And I end up getting negative 3x plus 1 in the end. Okay, so this is my what? This is my remainder. How do I know I can't go any further? Even if you tried to, if I asked you how many times can 3x squared go into negative 3x, you'd have to be like, I can't do that, right? Because the x power is bigger here than it is here. So that's when you stop, by the way. When the power here is smaller than the power here, that tells you that that's your remainder. So the answer in all its ugly form is what? What we got up top, which was what? 6x squared plus 3x minus 1. and then plus whatever your remainder is, so it's negative 3x plus 1, and then over what we were dividing by. So this is not a great day to, zone out or not be in class, because I think you can see this looks a little more challenging than it really is, right? It's really just the same 3 steps repeated over and over. But can we agree that this looks ugly if you're just like glancing at it and you didn't go along with me, right? So that's why I really want you to learn the process, okay? But just remember, this is really not that much different than what process from elementary school? From straight up division of numbers in elementary school, right? It's just been a long time since we haven't had a calculator in front of us, right? We love the calculator, and I understand why. But if you can just try to remember back to when you didn't know how to use the calculator, or your teacher didn't let you use one, then that process should be kind of obvious. Okay, so long division's kind of a booger. Okay, I think we can agree with that, right? It's kind of a long process. That's why it's called long division. Synthetic division is actually shorter. But it's not going to look like it when I write out the steps. Okay, just know that to explain the process takes longer than to actually do the process. Once you get going on synthetic division, I think you're going to find out that you probably like it better than long division. But we're not allowed to use it all the time. So you're allowed to use this when you are dividing polynomials that are very simple. So you're allowed to use synthetic division when you're dividing by x plus or minus a number, okay, as the divisor. Where c is a constant. So just know that the process is easier, but there's a lot of examples that we just finished that would not work with synthetic division, okay? Examples. If you look above the ones we just did, the only one that would have been a candidate for synthetic division was example 1. Okay? Examples 2, 3, and 4 we're dividing by things that are too difficult to be able to use synthetic division. Okay? So synthetic division is great, it's quick, but it just doesn't work for everything. So that's kind of my disclaimer there. All right, so stay with me with the steps, and I promise you're going to find that it's actually a much quicker process. So step 1 is you line up the coefficients. Coefficients are just numbers in front of variables of the dividend. If you don't know what dividend means, that is what is being divided, the bigger thing. An important thing to note is you have to have a number for every power of x. So you need to include zeros for missing terms. Step number 2, I'm going to put a star by this one, not because it's hard, but because lots of people forget it. Okay. Step number 2 is to change the sign of the divisor. And if you're not sure about your vocabulary, divisor is what you're dividing by. So the dividend is the bigger power thing that you're dividing into. The divisor is the smaller power thing that you're dividing by. So this is what is being divided. This is what you're dividing by. Step number 3 is you bring down the first number. And then you multiply that by the divisor and put the result in the next column. And then you add down the column. And step number 5 is you just repeat this two-step process, multiply and add until you run out of numbers. Notice that in this process, we're not multiplying then subtracting, we're multiplying then adding. Okay, we're going to talk about why that is in just a minute, but just know that the process is just a bit different. And then the last step is really just about evaluating what you have. You're going to write your answer as a polynomial. Really important that you remember, but the last number is the remainder. And then the numbers kind of count up from there. So if the last number is 0, what does that tell us about our remainder? The remainder is also 0. Okay. So the process is explained really in a wordy way, but you're going to find that it's very, very fast once you get the hang of what this is. So let's practice one, and we'll go through all of these steps. So let's say I asked you to do this division. Okay. Now you could still do long division on this. Okay. But why is this a candidate for synthetic division? Yeah, so notice the reason we can use synthetic division, so I'm going to say we're going to use synthetic here. Since the divisor is simple. It's x plus or minus c, right? You wouldn't be able to do it if it were anything more complicated than that, okay? So here's what it looks like. First, you just line up the numbers in a row. So 2, 7, 9, and negative 20, and leave a little bit of space between them. And then the divisor goes in kind of a little half box there, but you change the sign of the divisor. In other words, you're actually concerned with what makes the denominator 0, not the number itself. So what would you change 3 to then? Negative 3, okay? And then skip a row and put a line here because we're going to continue to add and multiply and all that good stuff. So you always bring down the first number, and then you just start multiplying and adding, multiplying and adding. So you take 2 times negative 3, which is what? Negative 6, and you line that up in the next column. Okay? And you always add down the column. So what's 7 plus negative 6? 1, right? And then you do it again. 1 times negative 3, what do we get there? Negative 3, so where are we going to put that? In the next column. And then what are we going to do down the column again? Add up, right? So what's 9 plus negative 3? 6. And then last but not least, because we're about to be out of numbers, right? 6 times negative 3 is what? Negative 18. And if I add down the column, I get negative 38. Okay? So it's called synthetic division because you just pull the numbers out, you do your math with them, and then we're going to put the x parts back in. So what did I tell you this last spot is always going to be representing? The remainder. And then it just kind of counts up from there. This is going to be the constant, the number by itself. The next one up is going to be the x term, and the next one up is going to be the x squared term. Okay, so the answer then is 2x squared plus x plus 6. And then I always do plus the remainder even if it happens to be negative, and I just indicate that it was negative in the actual remainder itself. Okay, so the fact that we got a remainder, what does that mean? Does it divide in evenly or no? It doesn't divide in evenly, right? So what were the steps we repeated here? We multiplied, we add the column, and then we repeat. Okay, we just did that over and over and over and over. Okay, so how do you notice this is different from long division? It's the same process, really. It's just a little bit of a trick slash, that's why it's called synthetic. It's kind of a trick slash fake method of doing it, really. What you essentially do is change the sign of this so that you're adding rather than subtracting, right? What's usually easier for us to do in our head? Add numbers or subtract them? It's almost always easier for us to add them, right? So we changed the sign originally, and then we can just add throughout the rest of the problem. That is why we changed the sign, okay? It makes synthetic division quicker to do, okay? Before we move on to the next one, notice this was a cube divided by a first power. So what kind of answer should we expect then? A squared, right? Because if you take a cube third power divided by an x to the first power, you should get an x squared, right? Actually, with synthetic division, what should always happen to the power of what you're dividing by? Since we have to divide by something to the first power, what's basically going to happen every time? Like if we start off with fifth power, like in this example I'm writing, what will be the answer then?
You gotta be,
It'll be what power? Fourth, yeah. It'll always be one less, okay? Okay, so before we write this, I want you to kind of make note of this. Notice that we're missing what term? X to the fourth term, okay? So it's really important that you always have a place value for everything. So if you skip one of the terms, you have to put a what in its place? A 0. So we have to have a 0 for x to the fourth, -2, 4, -3, and 1, okay? So notice since we were missing the x to the fourth term, we put in that 0. What would go inside the little half box? Not 2, but what? -2? So maybe we can do this process faster. What do we always do with the first number? Always bring the first number down and then start your multiply add thing. Okay. So what do I do first? 6 times what? -2, right? What is 6 times -2? -12, so that goes there. And then what do I do down the column always? Add, so 0 and -12 is -12. And then I do it again, right? What's -12 times -2? Positive what? Positive 24. And then what? Add them, so you get 22, right? 22 times -2 is -44. Add down that column and you get -40. If you need to pause and use your calculator for some of these multiplications, you can, but try to do it without because it'll be quicker that way. And then what's -4 times -2? Positive 80. If you add those, you get 77. So maybe we need a calculator for this one since the numbers are getting kind of bigger and bigger, but 77 times -2 is actually -154. So what's going to go in the last spot then? -153, right? So what is this always? This is the remainder. This is the constant. This is the x squared, the x cubed, and the x to the fourth. Okay? If you wouldn't have put the 0 in, you would have had the wrong numbers first of all, and you would have ended up with the wrong power in the end. Okay, so just remember you should always be kind of one less. So the answer, it's kind of a long one. The answer is 6x to the fourth, and then what? Minus 12x cubed plus 22x squared minus 40x plus 77 constant, right? And then minus or plus actually -153 over x plus 2. Notice I go back to the original and figure out what I was dividing by. Okay, so that I don't have to worry about my signs being wrong, I always just say plus for the remainder and then I list it as negative if it's negative. Technically on this one though, you could have said minus the 153 over x plus 2, but that might mess you up on some of the more difficult ones. All right, so I want you to take like a minute or two and try one for yourself. So the first thing I want you to notice is, what do you notice about terms that have been skipped? There's a lot of them, right? So you need to think about that before you set it up. Okay, so I'm not going to say any more and see what you can get on that. So you can kind of check yourself, what power should your answer have ended up in? Should be fourth. So if it's not, then something's up there. Maybe you didn't put enough zeros or something like that. Okay, so let's go ahead and look at this now that you've done that together, or hopefully on your own, I mean. All right, so what are the numbers we line up? We have a 1 for x to the 5th, but then we're skipped x to the 4th, so what do we put in that spot? 0, and then we have a 1 for x to the 3rd. We don't have an x squared. We don't have an x to the 1st, and then the constant is -2. Okay, so if you didn't set it up like this, you're going to need to erase what you have because everything, unfortunately, will be different. Notice that these like work on each other. Every step uses the step before it, so unfortunately, if you mess up at the beginning, it does mess up everything after that. And then why did I change this to a 1? Because we changed the what? The sign at the bottom. Okay, so we get 1 brought down, and then 1 times 1 is 1. What do we always do down every column? Add. So 0 and 1 is 1. And then we do it again. 1 times 1 is 1. But when we add down that column, what do we get? 2. 2 times 1 is 2. Add down that column, we get 2. There's going to be lots of repeating numbers here. 2 times 1 again is 2, giving us a 2 there as well. And then lastly, 2 times 1 is 2. So notice this hasn't happened before in this method, but what did we get for a remainder? 0. So this is my remainder. Then what comes to the left of that? This is my constant, and then I start counting up, right? X squared, x cubed, x to the 4th. Okay. So my answer, hopefully that you got on your own, is x to the 4th plus x cubed plus 2x squared plus 2x plus 2. Okay. Notice I don't need to write a remainder, right? Because there isn't one, right? Also, kind of like we did at the beginning of class, since the remainder is 0, I can make another statement, can't I? Since the remainder is 0, then I know that x to the 4th plus x cubed plus 2x squared plus 2x plus 2 times the x minus 1 I started with must equal what? X to the 5th plus x cubed minus 2. Okay, why have I not been making that statement on the previous examples? Because I wasn't getting remainders of what? I wasn't getting remainders of 0. I can only make that claim when I'm getting a remainder of 0. So moving into what we're going to start doing Wednesday, this is actually what we're searching for. We're searching for remainders of 0 because what does that tell us? If the remainder is 0, what do we know about it? It goes in evenly, right? So this is going to be kind of where we're heading, and I want to at least touch on it here so that when we cover it on Wednesday, you're not thrown off. So a lot of times on test 2, this is actually how I might word a problem like this. I might say, okay, if I know x plus 3 is a factor of this x cubed equation, then I want you to find all the roots, and I want you to fully factor f of x. So notice I'm telling you that one of them already is a factor, right? So what do we know about x plus 3 when I divide it into this? It's going to come out how? Perfectly and with no what? No remainder, right? So let's go ahead and do that, because even though I told you that it's true, we actually need to know what the result is. Okay, so before we do this, by the way, do we know how to factor x cubed things, or is it pretty much just x squared things that we're most comfortable with? It's really just x squared, right? We haven't practiced factoring x cubes, okay? So that's why I kind of had to give you an answer to begin with. So here's a 1. Bring it down, and then we just start multiplying and adding. So 1 times -3 is -3. Add down that column, and you get 4. 4 times -3 is -12. Add down that column, and you get what? -1. And then -1 times -3 is 3, which gives us our heavens opening up answer, right? That's what we want, because now we know the remainder is what? The remainder is 0. Okay, but remember, this is my constant, this is my x, and this is my x squared. Okay, so what I end up with then here is x squared plus 4x minus 1. So what I know from what I was saying before is that I know partially what I can do here, right? I know that x cubed plus 7x squared, which is what I started with, plus 11x minus 3, I know that it factors into x squared plus 4x minus 1 times x plus 3. Let me move that, sorry. Okay, and how come I know that? I can make that claim because what did I get for a remainder again? I got 0, right? So on the one hand, we have an answer here, okay? We have a root of x equals -3 here, okay? So this is a root, we already knew that. But also we have 2 more roots here. And how can I tell that I have 2 more roots there? What kind of power is it? It's squared, right? So I have one kind of nice root here, so I'm going to circle it. But I have 2 more here that I need to find, okay? So I either need to factor x squared plus 4x minus 1, okay? Or I need to use what on it? What do we do when we can't factor? Quadratic formula? Okay? Note that we can't factor this. Why do I say that? How come I know this doesn't factor? Try your AC method, and what do you notice? We'd have to be listing factors of -1 that add up to 4, and that's not possible, right? That's never ever going to happen. Okay, so we have to find the last 2 roots by doing quadratic formula. So I told you this was going to kind of come up again. We covered it before. It's going to kind of keep coming up. But what's quadratic formula again? -b plus or minus the square root of b squared minus 4ac all over 2a. So let's kind of plug in the numbers we have then. Okay, we have -4 plus or minus the square root of 4 squared minus 4 times a times c all over 2 times a. Okay, it's helpful if you say the formula as you write the numbers. So notice here I get -4 plus or minus 16 plus 4. Watch your signs really carefully. It'd be a plus 4 because it was a minus 4 times a minus 1. So I end up getting -4 plus or minus the square root of 20 over 2. Which is how many answers, by the way? 2, okay? But this is not reduced, so we did this during the first week, but I'm going to review it for you real quick, okay? If I break down 20 into a factor tree to see if I can reduce it further, what are 2 numbers that give me 20 when I multiply by them? 10 and 2 or 4 and 5 would have worked, okay? But remember, you don't stop until you get what kind of numbers in this factor tree? Prime. So notice we got square root of 20, right, is the same as 2 times 2 times 5. And we're looking for groups of 2 that get to come out. Okay, so I'm just kind of trying to remind you what we did the first week. I'm not really going over this fresh. You should be able to refer back to that first week notes. But this becomes 2 square root of 5. So that's what I'm going to put up here. So I get -4 plus or minus 2 square root of 5 over 2. But then notice that what is there in everything that might be able to go away now? There's a 2, right? So it goes away with this, that leaves a 2. So I end up with -2 plus or minus the square root of 5. Okay, just know that this is actually 2 answers in itself, right? So I got 3 roots. Why did I expect 3 roots, by the way? What kind of power did I start with? Started with cubed, right? So notice I had the nice root of -3, but then I also had -2 plus square root of 5, and also what? -2 minus square root of 5. Okay, so our process that we're going to start fresh with on Wednesday is pretty much this. We're going to do synthetic division, if possible. We're going to do synthetic division to find the nicer roots, or maybe you'll be given the nicer roots ahead of time. And you're going to do that until you're down to an x squared equation. And then you're going to either factor or use quadratic formula. So then you're going to factor or use quadratic formula for the last 2 roots. Okay. By the way, this is also part of the answer because I think I asked you to fully factor the original equation. So how come I didn't factor the first part more? Because I couldn't, right? That's why I had to use what formula instead? Quadratic formula, okay? So how many times would we say this graph crosses the x-axis then? 3 times. It's just once nicely and once at decimal values, okay? So we're going to do much, much more synthetic division when we come to class on Wednesday. So really make sure that you understand that.